The SKILL.md standard, your enterprise guide to AI grounding. Why? Structured instruction files are the hidden lever behind 20 to 50% AI performance gains and how to implement them across your organization today. The numbers tell the story. Structured prompts improve AI performance by 20 to 50%. Over 87,000 skills are already indexed in the SKILL.md marketplace, yet only 23% of enterprises can measure their AI ROI. Part 1. The grounding problem, why 84% adoption doesn't mean ROI. The enterprise AI paradox of 2026 is stark. 84% of developers use AI tools daily, yet only 23% of organizations can measure any ROI from their adoption. CEOs are optimistic, budgets are surging, and developers swear their work is faster. So why doesn't the data match the enthusiasm? The answer is a grounding problem. Giving AI models structured context about your team's conventions, patterns, and workflows. Without it, every AI interaction starts from zero. The model doesn't know your coding standards or deployment workflows. It generates code that looks right, but fails in review. A 2026 Microsoft research study titled Beyond the Prompt analyzed 401 GitHub repositories containing instruction files. It identified 5 recurring themes: conventions, guidelines, project info, LM directives, and examples. Every high-performing team independently converged on the same structure. The evidence is striking. Structured prompts that include explicit context and examples consistently achieve higher accuracy than free-form queries. An EMNLP 2025 survey found that optimized prompts improve correctness by 20 to 50%, delivering up to 3,400% ROI compared to ad hoc prompting. As you can see in the chart, the convergence from fragmented instruction formats to an open standard happened in under 18 months. Within weeks of Anthropic's December 2025 Agent Skills release, OpenAI, Microsoft, and major AI code editors adopted the standard. In December 2025, Anthropic released Agent Skills specification as an open standard, and the industry converged within weeks. OpenAI adopted it for Codex, Microsoft integrated it into Copilot, and every major AI code editor, Cursor, Windsurf, Claude Code, now supports SKILL.code, now supports SKILL.md files, alongside their legacy formats. The SKILL.md marketplace, a public index of reusable skills, now contains over 80,000 skills created by developers. The gap between AI helps me code and AI helps my team ship is no longer a mystery. It's a grounding problem, and it has a solution. Part 2. Anatomy of a skill. What makes SKILL.md work? A SKILL.md file is deceptively simple. Structured markdown that tells AI tools how to behave in specific contexts. It sits in a clear hierarchy of AI memory. This hierarchy matters because each layer persists differently. Project instructions live in your repo and update with your codebase. Skills are invoked when needed, either automatically context-triggered or manually user-invoked. RAG pulls in relevant documents on the fly. Conversations are forgotten after the session ends. As you can see in the chart, the AI grounding stack, persistent context layers reduce the burden on each conversation. Skills provide the middle layer between project-wide rules and ephemeral chat. How SKILL.md differs from alternatives. System prompts baked into the model, static across all users. You can't change GPT-4's system prompt to enforce your team's coding style. Skills are user-controlled and context-specific. Retrieval augmented generation dynamically retrieves relevant documents at runtime. Great for finding information, but doesn't encode instructions. RAG tells the model, here's what the API looks like. Skills tell it, always validate inputs before calling the API. Fine-tuning retrains the model on your data. Expensive, thousands of dollars, permanent, can't easily update, and overkill for instruction following. Fine-tuning is for teaching the model new knowledge or behaviors. Skills are for enforcing team conventions. The structure of a skill. A minimal SKILL.md file has 3 parts. The front matter, written in YAML, a simple key-value format, uses a user NZARC invocable flag to control activation. If true, users can manually invoke the skill via a command, e.g. coding standards. If false, the AI triggers it automatically based on context clues in the conversation. Part 3. Your first skill. Start here, today. The best way to understand skills is to create one. Below is a minimal but realistic example, a coding standard skill that enforces your team's TypeScript conventions. This skill is 20 lines and takes 10 minutes to create. Save it as .sclaude scoding standards SKILL.md in your repo now. Every time a developer asks Claude or Cursor to generate code, the AI will automatically apply these rules. The 3 starter skills every team needs. Don't try to boil the ocean. Start with these 3 high-impact skills. These 3 skills alone account for most of the code looks right but fails in review problems teams face with AI-generated code. Tips from the field. Cursor's team published a guide to agent best practices after analyzing how successful teams use their product. Their key lessons. This is the key insight. Skills evolve with your code base. They're living documents that capture patterns as you discover them, not comprehensive style guides written in advance. Part 4. Planning your rollout. From one skill to org-wide standard. BCG found a striking pattern. Organizations that focus deeply on fewer AI use cases achieve over 2 times greater ROI than those scattered across many. The lesson is clear. Depth beats breadth. Better to have one team using skills extremely well than 10 teams using them superficially. BCG, focused wins over scattered. Top-performing AI organizations concentrate on fewer, deeper use cases. They achieve 2.1x greater ROI than organizations that spread AI efforts thinly across many initiatives. Apply this to skills. One team doing it right is worth more than 10 teams doing it wrong. Here's a 3-phase rollout that balances focus with scale. Phase 1, champion team, 4 weeks. Phase 2, department rollout, 2-3 months. Phase 3, organization, 6+ months. As you can see in the chart, 3 phases from champion team to org-wide standard. Each phase doubles the number of skills and halves the time to value. Cross-platform teams. What if your team uses Cursor, Claude Code, and GitHub Copilot? Good news! GitHub Copilot now supports CLAUDE.md alongside its own Copilot instructions.md format. This means you can write instructions once and use them everywhere. The convergence to open standards happened faster than anyone expected. Take advantage of it. Part 5. Measuring impact, the metrics that actually matter. Here's the uncomfortable truth. Developer self-reports diverge wildly from measured reality. DX found real organizational improvements of 5 to 15%, not the 50 to 100% vendors claim. And in METR's controlled study, experienced developers were actually 19% slower with AI tools, despite feeling 24% faster. Why the disconnect? Developers feel faster because AI auto-completes code quickly. But Pharaoh's AI's analysis showed that while individual coding speed increases, delivery velocity doesn't improve, because coding is only one part of shipping software. Review, testing, debugging, and deployment still take the same time, or longer, if AI-generated code has subtle bugs. Skills this gap by reducing rework upstream. As you can see in the chart, developer perception consistently outpaces measured reality. Instrument delivery metrics, not self-reports. A 3-tier metrics framework. We recommend measuring AI impact across 3 layers, drawing on DX research and DORA metrics, the industry standard DevOps performance indicators. Leading indicators. Track weekly. These metrics tell you if adoption is happening. If usage is flat, dig into why skills aren't being invoked. Are they too broad? Too narrow? Wrong context triggers? Process metrics. Track monthly. These are proxy metrics for velocity. If skills are working, you should see fewer review cycles, AI-generated code passes review on first try, and shorter merge times, less back and forth. Outcome metrics track quarterly. These are lagging indicators of quality. If skills encode best practices, you should see fewer production bugs and less rework over time. The TAG framework, machine versus human versus hybrid. One effective approach is tagging code contributions by origin to measure AI impact cleanly. This lets you compare bug rates and rework rates across categories. If machine-generated code has a higher bug escape rate, your skills aren't working. If human-verified code performs identically to human-only code, your skills are working. The 3-6 month measurement window. Don't expect immediate ROI. AI adoption follows a J-curve. Productivity dips initially as teams learn new workflows, then recovers, then exceeds baseline. Budget for a 3-6 month measurement window before drawing conclusions. Early drops are normal. It means people are learning. The 80,000 plus skills in the SKILL.md marketplace all started the same way. One person solving one problem. They didn't try to encode every convention, pattern, and guideline their team had ever used. They wrote down the one thing the AI kept getting wrong. Create one skill today. Your team's coding standards. Save it as dogfood skills/coding standards/kill.md. Check it into Git. See what happens. When the AI stops making that mistake, create another skill for the next pattern that emerges. That's how grounding works. Not all at once, but one skill at a time. Thanks for watching. Read the full article with all the data and sources at ectoral.dev.